Yes, Assalamualaikum warahmatullahi wabarakatuh. Let's recite umur kitab Al-Fatihah before start our class lah. Yeah. Okay. Thank you for joining the class today. Okay, so today our topic is about Math Foundation. Okay. So Math Foundation is the also a shallow foundation lah. Yeah. Okay, the slide. The slide I already shared in Google Classroom. Yeah. Good. Okay. So can you see my slide, student?
Yes, madam.
Okay, let's proceed to our lecture. So today our lecture is regarding to Math Foundation. Okay. So Math Foundation is one of the shallow foundation lah. Yeah. So instead of using single foundation and pad footing, yeah, if we have really weak soil, yeah, meaning that the soil bearing capacity is low, yes, then you can use mat foundation lah, yeah, and the mat foundation can reduce differential settlement lah, yeah. So what is differential settlement? Differential settlement is when we don't want our structure to have unequal settlement lah, yeah. So some area settle, some area not settle, yeah. So if you have a weak soil, so if you use a pad foundation, yeah, pad footing, okay. So if some of the area settle, then some area of the area will remain, so that you can see the crack lah on your structure, yeah. So if you mat foundation, yeah, if the structure settle, so it will settle together, so you won't see the resistance of the crack can be reduced lah, yeah. Okay, or you won't see the crack lah, because the structure settle, it will settle together, yeah. Won't occur differential settlement lah, right? You will reduce the differential settlement. All right. Okay. So for the introduction, can you see? Can you hear my voice, right, student? Clearly.
Yes, madam.
I hope the video is not lagging. Yeah. All right. If the video lagging, please let me know lah. All right. Okay. So for the introduction, under normal condition, square and rectangular footcal are economical for supporting column and wall, yeah. As I mentioned, you can use square or rectangular footing lah, yeah, for under your wall and column, yeah. But certain circumstances, okay, your desire to construct a footing, yeah, for a line of column lah, yeah, 2 or more column, yeah. Okay, and the foundation, yeah, that cater line of column, or meaning more than one column, it called combined footing lah. All right, when more than one line column is supporting by concrete slab, it called mat foundation. Okay. So if you have more than one column, yeah. So one column you can use pad footing lah. Okay. Right, pad footing. Okay. If you have more than one, yeah. So if you have a lot of columns, so you can have mat footing lah, to support your structure. Okay, the mat foundation are generally used with soil that have low bearing capacity lah, as I mentioned before. Right, and then the combined footing can classify as a following. So we have rectangular combined footing, trapezoidal combined footing, and strap footing. Okay, so this is the photo of the rectangular combined footing. Yeah, so when you have more than one column, so you can combine lah, the footing, right? And then this is the parameter of the of your this is the column, this is the combined load, this one resultant load, combination of column of the loads from column 1 and column 2, so Q1 plus Q2 lah, right? And then X is the location of the resultant load, right? L is the length of your foundation lah. B is the width of your foundation. Okay, so combined footing, when you have 2 or more column, you can support it using rectangular combined footing lah, right? Okay, so this is the equation, to get the parameter lah, okay. So A is the area of the foundation. To calculate the area of the foundation, A equal to Q1 resultant of the column load, Q1 plus Q2 just now here, Q1 plus Q2, divide by Q net all. Q net all is the net allowable soil bearing capacity. So you have to remember the parameter lah. Okay. Determine the location of the resultant of the column load. To determine this one, the resultant of the column load. Okay. The location of the resultant column load here. To calculate for the X, so this is the equation lah. X equal to Q2 plus L3. So is L3. L3 is here. Column to column. L3. The length. Center to center of the column lah. That is L3. The length is L3, and then this one is a resultant of the Q1 plus Q2. And then to calculate for the L, L is the length of the foundation. So this is the equation, right? And then to calculate for L1, so where is L1? L1 is here. Here, L1. To calculate for the L1, so this is the equation, L, the length of the foundation, minus L2 minus L3. Here. L1 equal to L minus L2 here, and L3 lah. You can get L1, right? Width of the foundation, is equal to B. B is the width of the foundation, equal to A, area over L, length of the foundation, right? Okay, so then we move to trapezoidal combined footing. Sometimes used as an isolated spread footing of column carrying large load where the space is tight. So if you have space constraint, by example, you have another structure here, so this is the plan view one. So this is your column. But for example, you have another building here, yeah. So you cannot build rectangular footing in. So you can design for the trapezoidal combined footing lah, yeah. Okay, so you have a choice. Even though you have a space constraint, you can design for the foundation also. You can use trapezoidal type of combine of the foundation. Yeah. So, okay. So L is the length of the foundation. Yeah. B1, B2 is the width of the foundation. Okay. Right. So this one is the same previous photo lah. This one, the location of all of the parameter. Okay. Okay. So to calculate for the A, yeah, if the net allowable soil is known, yeah, net allowable bearing capacity just now, Q net. You can calculate for A. Calculate for A using this equation lah. Okay. If you don't know the net allowable soil pressure, so you can use this equation. Yeah, A equal to B1 plus B2, the width of the foundation just now, divide by 2 times length of the foundation. Okay, and then calculate for X. Yeah, the location of the resultant column load lah, X here. Yeah. So X equal to Q2 times L3 over resultant of the column load lah. Yeah, Q1 plus Q2. Okay. And then from the property of the any question, student?
Madam, ada seorang tak boleh
Yes.
masuk. Dia request 10 dari tadi dekat.
Cannot get in.
Dia request tadi lagi.
Why? What happened? Other student can join the class. You cannot
Dia dah request.
request. No. I need to allow the student. They automatically allowed. I don't know what happened. So who is the student?
Now,
You already joined now? Naufal? Naufal, are you here?
Yes, madam. Yes, madam. Thank you.
Okay. Why are you late?
No, I'm not late.
Why are you late?
I wait for many minutes.
Just now I start at 10:05 now. If you come early, then you can join the class without any problem. So please, next time.
Okay, I'm sorry.
Okay, let me share the slide. Can you see my slide, student? Am I sharing my slide?
yes, madam.
Okay, so let's proceed to lecture. Okay, mana dia tadi? Here, So, from the property of the trapezoid, so you can calculate this one lah. Yeah, X plus L2, yeah, X plus L2, yeah, equal to this equation. All right, and then with known value of A, L, X, and L2 can solve above equation to obtain B1 and B2. Yeah. So if you need to obtain the width of the foundation, yeah, so you can use this equation. All right. Okay. Note that for trapezoid, yeah. So this is the constraint. Yeah. Okay. You have to follow this one. Okay. Okay. Now we move to cantilever footing. Okay. For the cantilever footing, use a strap beam to connect an eccentrically loaded column foundation to the foundation of an interior column. Yeah. So the strap footing, you can combine the if you this is your wall, okay? This is your wall. If you have space constraint, yeah, to build for the foundation here, yeah, you can use the closer or the next of the area, the foundation, yeah, to help, yeah, in holding the loads, yeah. So this foundation, yeah, will help to hold this one, the load from the wall, yeah. And if the other circumstances where this one, yeah, the allowable load bearing capacity is high, yeah. For example, this area is low, yeah. The capacity the capability of the soil to holding the loads, yeah, at this area is low, yeah, and this area is high. Then you can use the strap beam, yeah, to help lah. So this area, this foundation will help lah to hold this load also, yeah. So is the function of the cantilever footing lah, yeah. Okay. So the adjacent load foundation will help to carry the load next to it. All right. Is it clear, this one? Student? For the cantilever footing, the purpose of the strap beam?
Yeah, hello.
Okay. Okay, if you have any question, just switch on your mic and ask lah. Yeah. Yeah. So that is the purpose of the strap beam. Yeah. To help in holding the loads lah. Alright. Okay, so for the example 1 and example 2, yeah, I will give in a separate session lah. Yeah. Alright. As usual, like a previous lecture, I will give in separate session for the examples. Yeah. Okay. Now we move to common type of mat foundation. Just now we learned about the combined footing, and okay. Now we move to mat foundation itself lah. Yeah. So mat foundation is also known as the rough foundation lah. Yeah. Is a combined footing that may cover the interior, yeah, under the structure supporting several column and wall. Yeah. So if you have, by example, you want to build guard house, for example, yeah. So you can have, you want to build a guard house, yeah. So this is your guard house. Okay, so you can have mat foundation lah, yeah, to hold your entire structure, yeah, the wall and the column lah. Okay. Mat foundation are sometimes referred for the soil have low bearing capacity. This one I already mentioned in. But that will have to support high column load. Yeah? So this structure will support very high loads lah, because it support all the loads from the structure. Okay. Under some conditions, spread footing will have to cover more than half of the building area, yeah, and the mat foundation might be more economical lah. Yeah, if the foundation, yeah, cover the spread foundation cover half of your structure, might as well you use mat foundation lah. Yeah, so one foundation cover the entire building. Yeah, loads. Right, it will more economical lah. Yeah. Right, so this is the common type of mat foundation. Right, so number one, yeah, here, number one is referred to figure A. Yeah, the mat is of uniform thickness lah. Yeah, so you have uniform thickness of mat foundation. Okay, and then number two, yeah, you can have the foundation, yeah, where you thicken only at the column area. Thicken the area at the column. Yeah, so you have the structure like this lah. Okay, and then number three, yeah, refer to figure C. Yeah, the column run both way. Yeah, and the column are located at the intersect of the column of the beam. Yeah, so you can have the beam, you know. Yeah. Okay, and then the location of the column, yeah, should be intersect lah. Okay, so if there's a beam, so the column is in the center here. Right, so this is a section view. This is a plan view lah. Okay, for flat plate with pedestal. Yeah, so this is the pedestal lah. Okay, and then slab with basement wall. Yeah, so if you can have also the basement lah. Yeah, for the parking. Yeah, the wall act as a stiffener for the mat. Yeah, so the wall here can act as a stiffener for the mat foundation. Yeah. Okay, so this is the this figure, yeah, to show you what is the and what is the B, the width of the foundation. Yeah, so please remember, yeah, DF is the depth of the foundation. Don't ask me in the exam, yeah. So you have to familiar with the parameter here lah. And right, what DF is the depth of the foundation. Yeah, B is the width of the foundation. Because this parameter will be used in the equation, so you have to memorize. Yeah, what is DF, what is the B. Yeah, so DF for straight footing. Yeah, so this is a DF lah. Okay, and for the mat foundation, yeah, so this is the DF. Okay, from the depth of the foundation, you should consider that the DF, the depth of the foundation, is the length, the depth between the surface of the ground to the bottom of the foundation. Yeah, so that is the DF. Right, for this one, yeah, from the edge of the structure to the the end of the foundation lah, ni. Yeah, so this is a DF. Okay. Okay, where the water table is high, yeah, the mat foundation are often placed over pile to control buoyancy. Yeah, so if you have high water table, yeah, you don't want your structure um you don't want your structure floating, yeah, because of the high water table, yeah. So you can apply column lah. You can apply pile. You can apply pile at the bottom of your foundation. So you can control lah your pile, yeah. Control the buoyancy lah. Okay. If not, then your foundation will float lah, because it's high water table. Yeah, meaning that the groundwater is high lah. The level of groundwater is high. Yeah, so sometimes you need to apply pile under your foundation. Yeah. Okay, so this is the example, the photo, yeah, of the construction of the mat foundation. Yeah, a flat plate mat foundation under construction. Okay. So how they construct this one? Any idea?
Maksudnya?
Anyone want to try?
They dig
How
the
they
hole.
construct this one?
They dig the hole. After that, put a lot of steel. Pour the concrete. Done.
Apa tu? How about when they apply this one, formwork? Ni, got formwork here, right?
They apply formwork around the mat foundation.
Okay. So when?
Before we make foundation.
When they should apply, install the,
Sebelum
Okay, first they have to dig the hole. First they have to dig the hole. Okay, and then after that they need to
framework the formwork. Put the formwork or the reinforcement steel first.
They need to have lean concrete. You know the lean concrete?
No.
Then they have, after they dig, yeah, they put lean concrete first. Okay, lean concrete, the grade of the concrete normally is 15, grade 15 lah. Yeah, and then only then they can put the reinforcement. After and also the formwork lah. Okay, and then between that, yeah, they have a spacer ni. Yeah, what is the purpose of the spacer?
Untuk naikkan steel tu, tak bagi rapat sangat ke bawah. Maksud ada jarak.
Okay, the purpose of the, okay, that's true. The purpose of the apa tu, spacer ni, yeah, to give a space between the earth, yeah, to between the earth and the reinforcement, yeah, to get the cover, yeah. Okay, because when you design for your structure kan, you need to allow some cover kan, yeah, to get the cover, yeah, the cover of your structure. So you need to put spacer lah. Okay, and then after that you pour concrete lah. Yeah, and then you need to cure the concrete. All right, and then this one, what is this? This one?
Column.
Okay. This one is the starter of the for the column lah. Yeah. This is not the column. This is the, we call it starter bar. Starter bar for the column lah. Alright. And then apa lagi? Good. This one is also the starter bar lah. This one. Okay. Alright. And then this one for the piping lah, the white color one. Okay. So that is how they construct a mat foundation. Okay. Same goes to apa tu? Pad footing lah. Yeah. The method of the construction is also the same. Alright. And now we move to the any question on this one? Because I heard somebody is talking the sound from mic. Any question? No. Okay, now let's proceed. The next slide. Okay, bearing capacity of mat foundation. Yeah. So the gross ultimate bearing capacity of the mat foundation can be determined by the same equation as a shallow foundation. I think all of you familiar with this equation, kan? Yeah. So in a shallow foundation topic, yeah. Before this, you can see this equation, kan?
General equation.
So this is the general equation, yeah, for bearing capacity. Yeah, and then the net ultimate bearing capacity of the mat foundation is equal to QU minus Q lah. Yeah, this one. Yeah. A suitable factor of safety should be used to calculate the net allowable bearing capacity. Yeah. So normally for the clay, remember this one. Don't ask me what is the bearing capacity again. Yeah. For the clay, normally the FOS, factor of safety should not less than 3. Yeah. So should be more than 3 lah. The FOS should be more than 3, under dead load and or maximum life load. Yeah. However, under a most extreme condition, the FOS should be at least 1 to 1.75 to 2. Yeah. So normally we use 3. Yeah. Is some condition. Yeah, you really the project is critical and the loading is the soil is really weak, so you cannot get the FOS 3. Then you can design for the FOS up to 1.75 to 2 lah. Yeah, but it's normal circumstances. Yeah, so the FOS should be more than 3. Yeah, to make sure your structure is safe lah. Right? And the mat constructed over sand, the factor of safety of 3 should normally be used lah. Alright. Under working condition, the factor of safety again bearing capacity of mat of sand is very large. Yeah. So normally the factor of safety, for the bearing capacity failure of mat on sand is very large. Yeah. Normally we will get the factor for the same type of soil. Yeah. So you can get the FOS normally is more than 3. Yeah. Because the soil is good lah. Yeah. So you can get a higher FOS lah compared to clay soil. Alright. Okay, for saturated clay, yeah, remember for the saturated clay, yeah, the friction angle, yeah, equal to 0 lah. Yeah. Don't ask me when is if the mention, yeah, the type of soil is a clay, yeah, saturated clay or clay. Normally the friction angle is 0 lah. Yeah, a vertical load and a vertical loading condition. Yeah, QU, yeah, equal to this equation lah. So CU is the undrained cohesion. Yeah, and NC, NQ, and N gamma, this is the value lah. Okay, and then substitute the preceding shape and that factor. Yeah, so QU equal to this equation. Yeah, and for the net ultimate bearing capacity, so this is the equation lah. Okay, and for FYS, factor of safety, the net bearing capacity, if the FYS equal to 3, yeah, the net allowable bearing capacity become this one lah. Okay, use this equation. Alright, the net allowable bearing capacity for MAC foundation constructed over granular soil deposit, yeah, can be adequately determined from the standard penetration resistor number. Yeah, so this one, okay, when you do the test, you do SI, yeah, you will get the SPTN number. This one I will explain in the soil investigation topic. Yeah. Okay, for the SPTN value. Okay, so when you do the SI, yeah, you do the borehole. Okay, then you do you proceed with the standard penetration test. Then you get the value, kan? So you can use the value to get QNet lah. Yeah. Okay. So but in the equation normally they will give, yeah, the ST. Okay. But in the industry when you are working, yeah, the N60 you can get from the SI lah, soil investigation. Okay. N60, yeah, B is the width of the foundation, and SE is the settlement. Okay. So the settlement you also, this one you can get from the lab test lah. Okay. When you have all the parameter, then you can get the QNet. Okay. FD, yeah, so this is the equation for FD. Okay. With the when the width is large, yeah, the preceding equation can be approximately as this one lah. Yeah. Hence, the maximum value of is this one. Yeah. So QNet maximum, yeah, given by this equation lah. Right. Okay, bearing capacity of the shallow foundation are designed, yeah, for maximum settlement 25. Yeah, and the differential settlement of about 19. Yeah. So when you design for your mat foundation, you can allow the settlement, yeah, maximum settlement 25 mm, and the differential settlement is only about 19 mm lah. Yeah. So you have to design for this one. You have to take this one in consideration when you do the design lah. Yeah, when you design for your mat foundation, so you have to consider this one. Yeah, the maximum settlement should be less than 25, and the differential settlement should be less than 19 lah, mm. Right? But in accordingly, yeah, the customary assumption, yeah, normally in an industry, yeah, they will they set the maximum settlement normally is 50 lah. Yeah, but in general, yeah, they set the maximum settlement is 25. Yeah, but normally they set the maximum settlement is 50 mm. Yeah, so it depend on you lah. If you want to it is depend on you as a designer. Yeah, what is the value that you want to set for the maximum settlement lah? Yeah, you can set for 25 or 50. Yeah, it depend on you. All right. Okay, so the net allowable pressure applied on the foundation may express as this one lah. Yeah, so Q is the net allowable pressure given by this equation. Q is the loading of the loads of the structure lah. Yeah, the dead weight. Q is the dead weight of the structure and the live load. Yeah, so Q is the live load plus dead load lah of the structure. Okay, and the A is the area lah, area of the structure. Yeah. In all cases, Q should be less than or equal to Q net lah. Yeah. Okay. So Q equal to this one lah. Yeah. Q equal to gamma dF. Yeah. This one is the Q, actually Q. Okay. This one is Q net. Q net is the net allowable pressure equal to this equation. Q equal to gamma dF lah. Yeah. Gamma is the unit weight of the soil. Okay. dF is the depth of the foundation lah. This one. Okay. Again, Q is the loading from the structure. Okay. All right. I hope you know the parameter. Stand for what? Because in exam, yeah, sometimes one use the it will just mention the depth of the foundation. They won't use the parameter like dF, gamma. So you have to know the gamma is stand for unit weight. dF stand for depth of the foundation. Yeah. So is only then you can fill in the equation lah. Yeah. If you don't know this parameter stand for what, then it's problem lah when you want to apply in the equation. So that's why you have to know. Yeah. What is dF? What is gamma? Only then you can use that value in the equation. Yeah, so you have to understand and memorize that one. Okay. And then for the examples, I will give you in a separate session on Wednesday. Yeah, I will give this one on Wednesday. So during class hour, in a class hour, you can go through the example. Yeah. Okay, now we move to compensated foundation. Our class finished at 11:30, right? So we have another 30 minutes. Let's finish the slide lah. Yeah, compensated foundation. Yeah. Indicate that the net pressure increase in soil under a mat foundation can be reduced by increasing the depth of the foundation. Yeah, depth of the mat. Okay, so if you want to increase the capability of the soil to carrying the load, so you can deeper the foundation in soil. Okay. Compensated foundation. Yeah. Compensated foundation meaning that you excavate the soil and then put in your structure. Yeah, that is called compensated foundation lah. Yeah, you excavate your soil and put the structure. Macam tu. That is the meaning of the compensated foundation. Yeah. Compensated foundation extremely useful when the structure are to be built in very soft clay. Yeah. So if your soil, yeah, is a very soft soil, yeah, for example, soft clay, so you can use a foundation lah. Yeah. So you excavate the soil. Yeah. You excavate the soil. Okay. Excavate out the soil and then build your structure. Yeah. The deeper base is made below the higher portion of the superstructure so that the net pressure increase in soil at any depth is relatively uniform. So if the deeper you dig, so the net pressure will be increased. Yeah. So it will help you in holding the loads lah. So if you have very soft soil, so you excavate the soil and excavate the soil deeper lah, and then build your structure. Yeah, it will help in holding the loads lah. It will help the soil to holding the loads. Yeah, so that is one of the choice lah. Yeah, later when you are working, you are the designer, you have to decide. Yeah, your foundation, you have to design for your foundation. Yeah, so that you have to consider this one in your design lah. Yeah, if from the SI, yeah, you accounted that the area, yeah, the soil is weak, then you have this option lah. Yeah, you can design for the compensated foundation. Yeah, to help in holding your loads. Okay. For no increase of net pressure, yeah, on soil below the mat foundation, Q equal to 0. Yeah, so DF equal to this equation lah. Yeah, so when the Q is 0, yeah, so DF equal to, you solve, then you get this equation lah. Right, DF equal to Q over A gamma. Right, the factor safety against bearing capacity failure for partial compensated foundation, DF is less than Q over A gamma. Just now, this one. Yeah, so FS, factor of safety, equal to Q net. Yeah, Q net is the net allowable bearing capacity. Yeah, divide by ultimate bearing capacity lah, this Q ni. Yeah. Okay. So Q net, oh, this one is the, actually is a Q, this one ni, net allowable pressure. So this one is, let me make it clear, net. Okay. So factor of safety equal to ultimate net allowable capacity, allowable bearing capacity divided by net allowable bearing capacity. Yeah. So Q net ni equal to this one lah just now. Yeah. Net ultimate bearing capacity. Yeah. This one. Q net U ni is the net ultimate bearing capacity. And Q net is this one lah. Yeah. Is the net allowable pressure. Okay. You have to memorize what is the net allowable pressure. And so net allowable pressure is equal to this one. This equation. Yeah. And then Q net is equal to this one lah. Yeah. Q net U ni is equal to this one. Okay. But at the end, you have to memorize. You have to know lah. This one, if there's a question on this one, I will give lah. This one in the exam. The apa tu? The equation I will give in the exam. Yeah. So you have to know the Q net U ni, net ultimate bearing capacity is equal to this one. This long equation ni. Yeah. And then Fs equal to this one lah, Q net U ni divide by net allowable pressure. Ni, here. Okay. And then for the example, I will give you a separate session lah, this one. Okay, now we move to the average vertical crease. Okay, just now, any question on compensated foundation?
No.
Sudah?
Yeah, madam, it's okay. No. Yeah.
Okay, if there's no question, then we move to the next slide lah. Next topic is on average vertical stress increase due to a rectangular loaded area. Yeah. In the previous session, the vertical stress increase below the corner of the uniform loaded rectangular area was given by this one. Yeah. So to calculate for the average stress increase, is equal to this equation lah. Right? This parameter is the average stress increase immediately below the corner of the uniformly loaded rectangular area between the Z. Z is the depth lah. Yeah. H1 and Z equal to H2. Ada figure here. Yeah. So this is the H2. This is the this is H1. This is H2. Yeah. As I said, as I mentioned earlier, Z is the depth lah. Right? This is your foundation, your just now. Okay. So AH2 equal to this equation lah. Yeah. And IAH1 equal to this equation. Okay. Is in estimating the consolidation settlement under foundation, it may require to determine average vertical increase in only given layer. That is between Z1 and Z2 lah. Okay. So when you this figure, you need this figure to calculate for this one. Yeah, IAH2 and IAH1 lah. Yeah, this figure. All right. Okay. So that is the only explanation on the average vertical stress increase. Yeah. So to make you more clearly on this one, so you can refer to the example just now later on. Yeah. Oh. Okay. The example is missing. There's another example number 7 lah. Yeah, I will give you the example on this one so that it can more it will be clearer. This one on the average vertical stress increase due to rectangular loaded area. So because this one is just the equation kan. Yeah. To understand this one, I will give you the example to calculate for the average stress increase ni. Okay. And let me see. The missing mana? Let me look at the previous. Hilang Oh, dia dah ke atas. So this is the example. Yeah. For example number 6, yeah, is the it should be macam tu. Salah. Arrange the slide. Sekejap let me change. So example number 6 ni, yeah, here. Okay. So example number 6 is on the average stress increase lah. Yeah. Okay. To calculate for the consolidation. Yeah. Right. So to calculate for the consolidation, so you have to use this equation. Only then you can know the consolidation settlement lah. Okay. So actually this one, yeah, this equation, yeah, the consolidation settlement. Yeah, I will show you the example so that it will be more clearer. Yeah, because this one is just the equation kan. Okay. When we go through the example, then you will understand. You will know how to calculate the consolidation settlement. Yeah. Right? Any questions today? So we finish on the MAP foundation.
Excuse me, madam.
Yeah.
Just in slide number 8. This is about rectangular combined footing.
Combined footing. Okay.
Rectangular.
Okay. Rectangle combined footing. What is your question?
Here in,
This one.
yes, in trapezoidal, there is a question for if I didn't have the not a label soil pressure, but in rectangular there is no equation for that. Do you understand? Okay, go slide number 8.
Slide number 8.
Yes.
Okay.
No, 7. Sorry.
This one.
7.
7. Okay.
Yeah. Here there's a they said if the not allowable soil pressure is not determine the area for the foundation. Yeah. This is in trapezoid. We have two equations. one with a global
Yes.
soil pressure and one
Yeah.
without it. But in rectangular there is only one questions. So if you ask us in any question or any questions, you will bring the allowable soil pressure for rectangular, or there is another question there.
Yes. If the question, the net allowable pressure is given, then you can use this equation,
Okay.
If not given, then you need to use this equation.
Okay, this is for trapezoidal, right? But
Yes. You mean for the
yeah,
rectangular? For the rectangular, this is the equation,
yeah. Okay, if the not allowable soil pressure is unknown, is not unknown.
Oh. You can use. Oh, there is no equation here.
Yeah.
To calculate for the area, and area of the foundation, you just rectangular kan. So B times L lah. The area of the rectangular combined footing, the shape is like this kan.
Yeah.
Right? If the Q net just now, this one Q net allowable is not given, then you just use the sizing lah. So L times B, then you can get the A, right?
So I can use this equation.
Yes, if you don't have the net allowable soil pressure, to get the A, you just use B times L lah. Then you can get the A lah, the area.
Okay, I got it. Questions number 2.
Okay tak?
Yeah, okay.
Because just now, because the shape kan, the shape of the trapezoidal, kan, the B is different. So that's why they come up with this equation. Kan, B plus 2 over 2 times L. But for the rectangular, you don't need to have the special equation to calculate for the A. The A is equal to width times length lah.
Yeah.
I hope it's answered your question.
Yeah. Thank you. Yeah, I got it.
Okay. Alright. So any other question?
Thank you, madam.
Alright. So any other questions, student? So if no question,
No, madam.
So if there's no question, I will give the example on Wednesday. Yeah, I will give the example on Wednesday. So please go through the example during class hour, in a class hour. Yeah. So next week, this Wednesday we won't have a lecture, but I will give you the example so that you can go through the example during class. Yeah. I will give all 6 example day, so you can use the class hour to go through all the example. Yeah. Okay. Student. Okay tak?
Yeah, madam.
Yes, madam.
Okay. So if there's no further question, I hope everybody is clear on the explanation. Yeah. So thank you so much for joining the class today. I will share the slide after this.